Hey, so this is another video about using power series to take limits. So just remember, the Maclaurin series is a very specific type of power series. Alright, so again, you could solve this using L'Hopital's rule. I'm not sure you'd want to. It's a bit of a pain to do it. But let's take a look at how to do this using power series. So you're going to notice two things in here that you're going to be able to convert into power series. The first is cosine of x, and you would rewrite this as the Maclaurin series. That's sum from n equals infinity, negative 1 to the n times x to the 2n over 2n factorial. Now, when I'm working with limits, I much prefer to rewrite them out as the expanded form. So you see what might cancel and what might be able to divide out between the different series. So let's take a look. It's 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial, etc. Alright, so that's the first one we can take a look at. The other one is arctan of x. So arctan of x, what's that one? Well, it's okay if you don't remember, but we know that 1 over 1 plus x squared is the derivative of arctan of x. Remember, it's the derivative, not the integral, the derivative. So what does that mean? D by dx of arctan of x, well, this is equal to 1 over 1 plus x squared. I know a lot of people in the midterm confuse this, but the derivative of arctan gives me back this thing. Alright, so this I do know a sum for, a power series sum. And in fact, if you went through the calculation to get the Maclaurin series, you would get the same thing. So this is, from n equals 0 to infinity, it's going to be, well, it's negative 1 to the n, and that's because it's a plus here, so it's alternating, times x to the 2n, right? Instead of x, we have x squared, so it's x squared to the power of n. There we go. So it's x to the 2n here. Right, and this is equal to 1 minus x squared plus x to the 4, etc. So because we know the derivative of arctan gives me back this, I can integrate this to get back arctan. So let's integrate both sides. Arctan of x gives me, and I'm just going to take the integral here, right, because the derivative of this gives me this. So to get from here to here, I need to integrate. So negative 1 to the n, I'm just integrating x to the 2n plus 1 over 2n plus 1. Right, and of course you can either go in here and you can plug in the n values to get back what you would get, or you can just integrate term by term. And I get that. Right, I'm just integrating term by term. Of course, it's a plus c, but we saw last time for plus c that if we plug in x to be 0, the c is just 0. So we've done this numerous numbers of times. In fact, it was on assignment 8, I believe. Yeah, it should have been assignment 8, question 4a or something like that. Anyway, so we've got a power series, or as well the Maclaurin series, the same thing in this case, of arctan of x. We've got one for cos x, we've got one for arctan of x. The rest of them are just simple little bits that you can't really make power series out of, or you wouldn't really want to. So I've got, and I'm just going to write this again here because can't see it up there, limit as x goes to 0 of, can't seem to draw straight lines. Alright, there we go. Arctan of x minus x on the bottom. And on the top, I had cos x minus 1, and that was times x here. Alright, so let's go ahead and plug those in. Let's see if I can get them both in the same window. There we go. Alright, that'll do. So this is equal to the limit as x goes to 0 of 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. And that's just cosine of x minus 1, and then times x. Times x. And this down here, well, it is going to be x minus x cubed over 3 plus x to the 5 over 5 minus etc. And that is going to be minus x. So you can see here, we can do a little bit of canceling, right? Just like before in our last two examples. So the 1 will cancel with the 1 here. Sorry, that's my bad. I should have minus dot 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 inside here. So this keeps on going. So anyway, I'm going to have 1 minus 1 here, and this x will cancel with this x. So let's see what we get. So this gives me the limit as x goes to 0 of x squared over 2 factorial, and this is negative, plus x to the 4 over 4 factorial, minus x to the 6 over 6 factorial, and then plus dot dot dot. And this is multiplied by x on the outside. This whole thing is over negative x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7 plus dot dot dot. Alright. So, from here we can do one of two things. We can either bring the x inside here, or we could just divide the x into the bottom. So I'll do the first one. I'm just going to multiply this x into this out here. Actually, you know what I'm going to do? I'm going to factor out x squared out of this bracket. So this is kind of like how we would solve limits from last term. Not that I know what you guys did last term, or you all, not you guys. So from here, from all the terms, I can factor out a common factor of x squared. Right? So I can take out x squared, and that'll give me negative 1 over 2 factorial plus x squared over 2 factorial minus x to the 4 over 6 factorial, and I can't seem to read because this should be 4 factorial. 4 factorial. That doesn't look like 4 at all. Hold up. 4 factorial minus x to the 4 over 6 factorial, etc. And this would be x cubed now, right? I factor out x squared from up here. So it's x squared times x, so I get x cubed. How about on the bottom? What if I factor out x cubed on the bottom? Then I get negative 1 over 3 plus x squared over 5 plus x to the 4 over 7. Sorry, hang on, this should be a minus. I'm making mistakes left, right, and center here. Alright, so this is x to the 4 over 7 plus dot dot dot, and I factor out x cubed. Alright, well, what do you know? These things cancel. So if I'm to plug in 0 for everything in here, what would I get? For x squared, well, this just goes to 0. This would be 0. This would be 0. This would be 0. This would be 0. And I don't actually get 0 over 0 because these first two terms don't depend on x. These first terms in each of these series now don't depend on x. So I'm left with, if I apply the limit, this term and this term stay, and everything else goes to 0, right? Because everything else will have x in it and will go to 0. So I get negative 1/2. Yeah, 1/2 because 2 factorial is 2. Over negative 1 over 3. And that's just 3 over 2. Alright, so that would be my solution. And again, you probably didn't want to have to go through all this taking the derivatives for L'Hopital's rule, so this is actually a reasonable solution. So let's just recap. What did we do? We went and took a look at our expression. We realized cos x and arctan of x we could rewrite as power series. So we do that. So we rewrite cos x as the Maclaurin series. More importantly, it's a series centered around 0. So we have one for cos x. We have one for Arctan of X. So that was a little bit of work to get there, but that's okay. It should be something you're familiar with, sort of, at least, because you've supposedly done an assignment on it. But anyway, so I go in and I plug in cos x and I plug in arctan x, and I get these two series. In fact, the limit is designed so that some of these things would cancel out, and they do. And I factor out the highest power of x on the top and on the bottom so that they cancel, and I deal with whatever that's left over. Right? You plug in x to be 0. The first term of each of these, of the numerator and the denominator, were not dependent on x. So they weren't dependent on x, so I could just get this. Right? These ones each go to 0 because I can just plug in x to be 0. And so I do all that, and I get 3 over 2. Yep, that's the solution. Awesome. Feel free to email me if you have any questions. If you want a bit more clarification, let me know. All right. For your examples, there are cases where you would have to factor up the top, highest power on the top and highest power on the bottom, have some things cancel. There's one where you have to find the power series of ln of 1 minus x squared. So just remember, that is very similar to ln of 1 minus x. So as long as you find the one for ln of 1 minus x, then you can sub in the x for x squared. So that's how you'd be able to do that one. Anyway, hope that helps. All right, that's that. I'll see you later.